In this question, you have to find modulus and argument of complex number minus root 3 plus I. Your complex number is in the form of a plus bi. So we will get the real part of the complex number is minus root 3, which is less than 0, and real part of the complex number is 1, which is greater than 0. So we can say your complex number lies in second quadrant. So the modulus of the complex number mod z is given by under root of real part square plus imaginary part square. So we will get under root of minus root 3 the whole square plus 1 square, which will give us under root of 3 plus 1, or we can say your modulus is 2. Now, argument theta for second quadrant is given by pi minus tan inverse of b by a, where your b is 1 and a is minus root 3. So here we'll get pi minus tan inverse of 1 by root 3, which is nothing but pi by 6. So here we'll get your theta is equal to 5 pi by 6. So tada! We get modulus as well as argument of the complex number. In this question, you have to find modulus and argument of the complex number minus 1 minus root 3i. Your complex number is in this standard form of a plus bi. So we can say the real part of the complex number is minus 1, which is less than 0, and the imaginary part is minus root 3, which is also less than 0. So we can say complex number lies in third quadrant. So the modulus of complex number is given by under root of a square plus b square. So here we'll get under root of minus 1 square plus minus root 3 square. So here we'll get under root of 1 plus 3, which will give us modulus is equal to 2. Now the second quantity which we need is argument theta for third quadrant is given by minus 5 plus tan inverse of mod b by a. So your b is minus root 3 and a is minus 1. So here we'll get minus pi plus tan inverse of root 3, which is given by pi by 3. So we will get theta is equal to minus 2 pi by 3 as a argument. So tada! In this question, you have to convert the complex number in the polar form. Your complex number is already in the form of a plus bi. So we can say the real part of the complex number is minus 1, which is less than 0, and imaginary part is minus 1, which is also less than 0. So your complex number lies in third quadrant. Now let's get two required things for the polar form. The first one is modulus r, which is under root of a square plus b square. So here we'll get under root of minus 1 square plus minus 1 square will give us root 2. And the second required quantity is theta argument. For third quadrant, your theta is given by minus pi plus tan inverse of b by a. So let's substitute the value of imaginary part and real part. Your b is minus 1 and a is also minus 1. So we will get minus pi plus tan inverse of 1, which is nothing but pi by 4. So we will get minus 3 pi by 4. So we are ready to convert our complex number z into the polar form. R into cos theta plus I sin theta. Just substitute the value. Your R is root 2 and theta is minus 3 pi by 4. So here we'll get cos minus 3 pi by 4 plus I sin minus 3 pi by 4, or we can say root 2. Cos is even function, so it will be cos 3 pi by 4, and sin is odd function, so you'll get minus sin 3 pi by 4 I. So tada, we get polar form of our complex number. We have to convert our complex number in the polar form. It is already in the standard form of a plus bi. So we can say the real part is minus 1, which is less than 0, and imaginary part, which is coefficient of I, is 1, which is greater than 0. So your z is in second quadrant. Now for polar form we need two things. The first one is modulus of complex number under root of a square plus b square. Your real part is minus 1 and imaginary part is 1. So we will get r is equal to root 2. Now the second required quantity is theta. For second quadrant, your theta is given by pi minus tan inverse of b by a, where your imaginary part is 1 and real part is minus 1. So here we get pi minus tan inverse 1, which is nothing but pi by 4. So here we'll get your argument theta is equal to 3 pi by 4. So we get our required quantities and we are ready to convert our complex number into the polar form, which is r cos theta plus I sin theta. Just substitute the values. Your modulus is root 2 and theta is 3 pi by 4. So you'll get cos 3 pi by 4 plus I sin 3 pi by 4. So tada! We get our polar form of the complex number. We have to convert our complex number in the polar form, and it is already in the form of a plus bi. So we can say the real part of the complex number is 1, which is greater than 0, and imaginary part, which is coefficient of I, is minus 1, which is less than 0. So we can say your complex number is in fourth quadrant. Now to get the polar form, we need two things. The first one is modulus of the complex number, which is under root of a square plus b square, where your a is real part plus your imaginary part square. So we will get modulus is equal to root 2. Now the second required quantity is argument, and for fourth quadrant your argument is given by minus tan inverse of b by a, where your b is imaginary part and a is real part. So here we have to find tan inverse of 1, which will give us theta is equal to minus pi by 4. So we get both quantities and we are ready to convert our complex number into the polar form, which is r into cos theta plus I sin theta, where your r is root 2 and theta is minus pi by 4 plus I sin minus pi by 4. Now if we simplify, we will get root 2 into cos is even function, so we'll get cos pi by 4, and sine is our function, so we'll get minus sine pi by 4 I. So tada! We get our polar form of the complex number. Please remember that if you substitute the value of cos pi by 4 and sine pi by 4, we will get your original question. Here, you have to convert the complex number z is equal to minus 3 in the polar form. Your complex number is in the form of a plus ib, where the real part of the complex number is minus 3 and imaginary part, which is coefficient of I, is given by 0. Whenever we have imaginary part equal to 0, your complex number is purely real number, and here your z is less than 0. So we can say your z is on negative real axis. Now, to convert into polar form, we need two important things. The first one is modulus, which is under root of a square plus b square, where a is real part square plus b is imaginary part, which is 0, the whole square. So we will get modulus is equal to 3. Now, the second important quantity is argument, and for negative real axis, your argument is given by pi. So we are ready to convert our complex number into the polar form, which is r into cos theta plus I sin theta, where your r is 3 and theta is pi. So you'll get cos pi plus I sin pi. So tada! We get the polar form of our complex number. We have to convert our complex number in the polar form. The complex number is in the form of a plus bi, where the real part of the complex number is root 3, which is greater than 0, and imaginary part, which is coefficient of I, is 1, which is also greater than 0. So we can say the complex number is in first quadrant. Now to get polar form, the first quantity we need is modulus r, which is under root of a square plus b square, where a is a real part, which is root 3 square, plus b is a imaginary part, which is 1. So here we'll get your modulus is equal to 2. Now, the second required quantity is argument, and for first quadrant, argument is given by tan inverse of b by a, where b is imaginary part and a is real part. So your theta is tan inverse of 1 upon root 3, which will give us theta is equal to pi by 6. So we are ready to convert our complex number into the polar form, which is r into cos theta plus I sin theta, where r is modulus and your theta is argument, which is pi by 6. So you'll get cos pi by 6 plus I sin pi by 6. So tada! We get polar form of our complex number. Here you have to convert our complex number z is equal to I in the polar form. Now here your complex number is in the form of a plus bi, where a is real part, which is 0, and b, which is coefficient of I, is 1. Now whenever we have a equal to 0, then complex number is called purely imaginary number. So we can say your complex number will be on imaginary axis, and your b is greater than 0. Therefore, we can say it is on positive imaginary axis. Now, To convert into polar form, the first thing we need is modulus, which is under root of a square plus b square, where a is real part and b is imaginary part. So we will get modulus is equal to 1. Now, the second important quantity which we need is argument, and for positive imaginary axis, your theta must be pi by 2. So we are ready to convert our complex number into the polar form, which is r into cos theta plus I sin theta, where your r is 1 and your theta is given by pi by 2. So we'll get cos pi by 2 plus I sin pi by 2 as your polar form of the complex number. Ta-da!